ExactData specializes in generating synthetic data sets with rich and meaningful content tailored for your development and testing needs. In this video, we are presenting our concept for synthetically generating enterprise network traffic that is representative of the activities and interactions between employees in small, medium, or large businesses. Our mission is to transform our ability to model long-term interactions between employees and potential correlated threat patterns into realistic network traffic so that next-generation intrusion detection systems or behavioral analytics tools can be analyzed. To achieve this, we use our Adams data model, which models the interactions, social networks, and behaviors for any size business and is formatted as if it was the output of a host-based intrusion detection system. These logs contain the events such as the emails sent by employees, the websites visited, and the file transfers over the course of months or years, and we embed bad behaviors such as data exfiltration or employees exhibiting frustrations leading to malicious behavior. Some of these bad insider behaviors may take weeks to develop and may go unnoticed until it's too late. And it is extremely hard to detect as there are many other legitimate interactions going on at once. We call this the needle in the haystack. Our data model formats these behaviors in a packet abstraction language called Muscle, and through the packet generator Cyberflood by Spirit, we then can play our synthetic network behaviors over the network. The key benefit with synthetic data is that we can provide ground truth files describing exactly when malicious behavior manifests, which then can be used to derive detection accuracy or AI training and testing. We believe that data like this aids in limiting the number of false positives in the system and or decrease the amount of time IT personnel looks for threats in their network. With this, let's take a deeper look into our generation tool known as the Dynamic Data Generator and how we leverage it to generate network traffic. This is the UI controlling DDG for the Adams data model. Here we expose some example knobs to control the characteristics such as the time frame of the generated data and the number of employees to model. However, more importantly, the occurrences of malicious behavior like the number of times someone exfiltrates data through email or Dropbox is a configurable parameter, along with parameters to make behavior more obvious or difficult to detect. Running this data model will simulate the interactions of the employees over the time frame given the social network defined by Adams. And this will generate millions of records formatted in the desired output. Let's take a look at the email generated from the Adams data model formatted as a CSV file. The email data outputted from DDG contains attributes such as the time at which email was sent or read, the computer it originated, the sending email address, and the recipients. However, the most interesting feature here involves the content and the attachments. We generate the email contents relevant to the person's business, interests, and social networks, but this is where we also embed the needles in the haystack. Disgruntled employees may not immediately exfiltrate data, but show their frustrations to other employees or change their website viewing habits. This is the type of content that we would like to play over the network so they can be detected as early as possible. This is where we leverage a tool such as Cyberflood to format this data into a language which can be sent as network packets called a muscle file. A packet abstraction like muscle allows us to dynamically define the packet structure to account for various attachments, data type, and content. DDG will input the attributes such as the sending server IP addresses and the contents of the emails in which Cyberflood will interpret and send out as real packets over the wire. From the perspective of a Wireshark packet capture or an intrusion detection system, the packets sent out look as if they were a real request with realistic looking responses. Once the data is formatted as a muscle file, we then can take a quick look at the packet generation step in which our data is automatically sent to Cyberflood. The dashboard for Cyberflood is where we can see a variety of configuration parameters for the run duration, test network subnets, and other specific features. These parameters are specific to the system under test, and as we are data experts, we are interested in packetizing our own data and the data that can be generated by Cyberflood. Our data is not strictly malicious and contains normal traffic. However, a tool like Cyberflood can also inject normal-looking traffic that may be outside of the types of traffic that we can reproduce. This is called a traffic mix. The traffic mix feature in Cyberflood allows us to define distributions of traffic types such as HTTPS, FTP, SSH, or streaming services to be played while our synthetic data is intertwined. This feature will allow users to strain their system under test with even more data by configuring the tool to obfuscate our meaningful content with other high-volume content. As mentioned before, the purpose of this concept is to take rich synthetic content that describes events on a network and play them over the network as if they actually happened. We will now run DDG alongside CyberFlood and look at the data from the perspective of a system administrator interpreting their intrusion detection system logs. This is the dashboard for the data visualizer Kibana, where we have captured our synthetic network traffic using the intrusion detection system known as BRO. Here we can see that over the course of the short demo, we have collected an excessive amount of network events, which would make it very difficult for an analyst to determine which ones caused a security breach. Because we have synthetically generated this data, we do know where to look for our embedded malicious behavior within the normal data. In this case, our malicious behavior was in the form of emails. So now let's take a deeper look at the events captured by the sensor for SMTP traffic. As the traffic mix did not include any SMTP traffic, we can now see the contribution of our synthetic data for a small subset of employees. The overall number of events have been significantly reduced, and if we take a deeper look at the statistics of the events, we demonstrate that the content generated by our model are legitimate packets that can be captured by an external sensor. The actual contents of the email are not shown here, as this intrusion detection system is not intended to capture the contents, but just the event. Our data generation capabilities are not limited to just emails, but can be expanded to web traffic, file transfers, etc. We believe that the contents will play a major role in early detection of insider threats, employee dissatisfaction, but also outside threats. In summary, we have demonstrated our concept of packetizing synthetic enterprise network events and the capability of capturing this data over a network. ExactData specializes in synthetic data generation, and this is our first push into the cyber domain with groundbreaking content and packet generation.